Hello, welcome to Tech Talk Tuesday with Steve. Actually, Tech Talk with Steve. It is Tuesday and time change is hitting all of us. I don't know about everybody else, but I've been finding myself waking up at 4 o'clock every morning. So glad to have everybody here today. We're going to be talking about fiber. Obviously, the topic of today's discussion is got fiber. And we're going to talk about some things related to fiber. Jacqueline posted a question. Don't know if anybody noticed that, but we had a multiple choice poll question up there that I'm going to address. And we're going to cover some things that you may or may not already know about testing fiber and things to hopefully help make things go more smoothly when you are involved with fiber optic testing. So I'm going to go ahead and share my screen and I'm going to pull up a little presentation here. We're going to go through and talk about fiber, and then we'll do a live demo at the end. So we're going to talk about what is optical loss testing, why it's so important. We'll talk about the types of loss testing, and we're going to talk about hybrid powered fiber. Talk about how it's used, how we can test it, and make sure that it's ready for whatever we're going to use it for. We'll talk about some keys to successful testing, some things that maybe you've already thought about, maybe you haven't. We'll talk about whether or not the fiber will work for your application based on the test results. We'll examine some common causes of test failure, talk a little bit about documentation of results, and then we'll go on to the live demonstration. So the poll question that I mentioned at the beginning, what is one advantage of single mode fiber as compared to multi-mode fiber? A, it installs itself. B, it is better for your diet. C, it takes up less space because it's only a single fiber instead of multiple fibers. Or D, it has greater bandwidth. If you chose D, you're correct. It does have greater bandwidth, lower loss, which is attenuation, greater bandwidth, greater distance. So the main difference between single mode and multi-mode, and we actually threw that question about one fiber versus multiple fibers in there, because I do come across people sometimes who think that a multi-mode fiber is multiple fibers rather than one fiber. So there is a little bit of confusion there. So I wanted to kind of, explain a little bit of the difference between multi-mode and single mode. They're called multi-mode and single mode because on multi-mode, you have multiple modes or multiple paths of light traveling through that glass. And on single mode, it's a single light path or single mode. And this is kind of a cross section of fiber that we see here. So we see, the outer part of the glass is called the cladding. The inner part where the light travels through is the core. The cladding acts as kind of a container, if you will, for the light. It reflects and refracts the light so that it travels along that piece of glass, and it arrives at the far end in the correct order, in the correct sequence. So the difference between the two as far as the physical construction goes comes in that core size. The cladding size is going to be the same. It's 125 microns. It's the outer diameter of the actual glass. And then the core typically is going to be a 50 micron on the more popular fibers today for multi-mode. Some of the older legacy fiber is 62.5 microns. And then 9 microns on single mode. And a micron is that's, you're looking at 9 microns, you're talking about something that's smaller than a human hair there. So very, very, very tiny. So we're talking about a very small piece of glass here. The way the fiber's structured, you've got that cladding, that 125 micron cladding. And another point of clarification, just briefly here, I have actually heard people say that they strip the cladding off of the fiber. You do not strip the cladding off of the fiber. The cladding is part of the glass. You're not stripping cladding. What you're stripping is primary buffer and secondary buffer. So there's a small 250 micron clear buffer on there, sometimes referred to as an acrylic coating. That gets stripped off along with that plastic buffer that you can see that has some color to it. Again, single mode has that lower loss, and some examples here of the distances you can run for 10 gig Ethernet as an example. If we're looking at OM1, the old style 62.5 fiber, you're only 33 meters there, and you go all the way up to single mode, OS1 single mode, 2 kilometers, and 10K and beyond for an OS2. So there's quite a bit of advantage. Electronics have come down in price to where it's not as much of a barrier as it used to be for choosing single mode over multi-mode. So what is optical loss testing? In the old days, we'd have a standalone light source and power meter, and we'd take a measurement with a reference cord connected. We'd write that down, and then we'd go to the other end of the fiber with the power meter and have the light source connected to the main end. And then we would read that reading there, and we would physically do the math and calculate that loss. And we can see here's two examples of Test Pro and power meter mode. And initially we start with 2107 and negative 2107, and then we did a reading at negative 2109 when we connected to the device under test. The difference between those two is 0.22. So that would be our loss. Now we've got that all built into the test systems. Optical loss test sets do all this automatically. You set a reference and you run the test, and it does this calculation for you based on those two readings. Why is it important? So we need to test the loss on fiber because we're running data over it's going to cause problems with our data. Might be just a slow network, might be no network. You could have bad enough loss condition that you just can't communicate between point A and point B. Typically, a loss budget is determined based on the known transmit power of the equipment that's being hooked up and the known receive sensitivity, or that window of what strength signal that receiver can see. And you have a loss budget so that as long as you don't exceed the amount of loss that drops that signal below what that receiver can see, you're within that loss budget. And newly installed fiber or existing fiber, if you're going to reuse it, always needs to be tested. You can't just put it in and hope that everything works. It probably will, but you really don't know. So you'd rather test it when you install it rather than wait until you start to hook up equipment and find that you have problems. And typically your scope of work for project is going to require that you actually test that fiber. So some types of optical loss testing. There is a simple loss budget test. So we mentioned that loss budget earlier. So let's assume we have a loss budget of 3 dB. And as long as we don't have greater loss than 3 dB from the one end of the fiber to the other, we're within that loss budget. You can set the tester up to just do a loss budget test. And as long as it's 3 dB or less for loss, you're going to pass. If it exceeds that 3 dB, you're going to fail. Standards-based test, which is recommended, takes a lot of things into account. So it looks at the type and grade of the fiber that you're testing. It's going to set a limit based on your choice of the test standard that you choose for the loss per kilometer on the fiber in multi-mode case, 850 and 1300, or for single mode, 1550 and 1310. It'll also take into account the loss of the connectors at each end of the link. Also, loss of any additional connectors. For example, when you're testing from point A to point B, if there's an interconnect in between, an intermediate closet perhaps, where you've got two fiber panels and you've got a patch cord going between them, you have to account for those two mated pairs of connectors there as well. Any additional splices. So if you have a splice in that link, you're going to want to account for that too. And that's whether it's a fusion splice or a mechanical splice, you need to account for that. One question that often comes up when we talk about splices: what if I have mechanical splice type connectors that I'm putting on the cable? Do I count those as just a connector, or do I count those as a splice, or do I do both? You do both. It is a mechanical splice. You have two pieces of glass there that are mating together. You have to count that as a splice. And then you also have the loss for the connector at the end of the fiber as well, those mated pairs of connectors. So it's important that you get all the correct information entered into the tester up front. Here's just an example of a test that was set up using reference grade. We added, in addition to the reference grade fiber here, multi-mode, we have our two end connectors, which are automatically selected. Because it's reference grade, we only get 0.5 for each mated pair of connectors. Then we added another connector in the middle. So that would be a kind of a weird situation where maybe you had two pieces of fiber and you had connectorized them and put a coupler in between them. You'd have one. It's not typical, but we just did it for an example here. And then we have a splice. So we've got one splice in the mix as well. So when the test is run, these all come into play. So we get 1 dB for two connectors, two mated pairs. We get another 0.75 for this one, so we're at 1.75. We get another 0.3 for the splice, so that puts us as 2.05. And then when we run the test, you also measure length. And that length, you calculate out the loss per kilometer. And then by that length that you measured, we added another 0.10 to our loss allowance here. So 2.15 was our final number in this example. And again, you don't have to remember all this. You just input the information in this limit screen, and the tester does it all. It calculates that limit for you. So let's talk a little bit about hybrid powered optical fiber. So this is fiber that has a copper pair under the same jacket. Now, way back when hybrid fiber started coming out, we were talking about maybe a 5E and fiber under the same jacket. This is different. This is power. So we've got a copper pair that's designed to carry power. It could be anywhere from a 12 gauge to an 18 gauge typically, under the same jacket as the fiber. So used typically to provide power out to a remote device where maybe there's not power available, or a PoE extender that you're putting in that there's no power available. So you would carry your data over the fiber strands, and then you would have your power provided remotely over that copper pair. And in this case, we're showing an example of using the power meter and measuring the voltage, which you can do with Test Pro, as well as our network service assistant. So you can determine that, yes, I'm getting the voltage out at this location. You can also test resistance. So when you're testing resistance, you would do this with Test Pro, and you're doing a dual-ended fiber test, but you're also measuring the resistance of that copper pair, all in this same test adapter. So you don't have to have a separate meter, a multimeter, to measure voltage or resistance to be able to do this. And this information gets incorporated into that test result. So the reason we measure resistance, some of you that have attended our discussions on PoE know that resistance causes issues with power. If you have too much resistance, you can't get power adequately to the endpoint. So if you can use a calculation to look at whatever gauge wire you're using. You would know that you have to have a certain resistance in that loop. It needs to be that much or less in resistance to be able to handle that power. Once you install that fiber, you're going to measure it, and if you've exceeded that, if you get a high resistance value, you know that something's happened to that copper pair while you were installing. So this is really validating the integrity of that copper pair to make sure that you're going to be able to provide that power to the endpoint. Some keys to successful testing. So connector cleaning systems. So most manufacturers are going to ship, test equipment manufacturers are going to include some kind of cleaning device, a click cleaner, for example, with the equipment that you receive, the fiber test system, the optical loss test system. Click cleaners are good, but you should also have some additional cleaning supplies on hand. I recommend a wet to dry method that you keep in your available kit. Sometimes a click cleaner isn't going to get everything off, so you need to be aware of that. Visual fault locator is good. So, VFL, you want to be able to find a break at one end or the other, which typically you're going to get a break if it's going to happen. A lot of times it's going to be at one end or the other in that distribution panel. So having a VFL gives you a bright light to show you, yeah, we've got a break here. Or if it's a mechanical splice connector, you can see it reflecting in there if it's a bad connection. A visual inspection scope. So we can see here some examples using the visual inspection scope with the Test Pro. You can get a lot of dirt on these connectors, and we see down here before and after with clean and not clean. It's very easy to get a lot of dirt. Now, these two pictures in the upper right here were from light sources that I had to examine because the customer was having an issue with them, and they actually got a lot of dirt on the end face of the connector, and they needed to clean them, and they hadn't been cleaning it. So one of the biggest causes of failure out there is dirty connectors. And you get dirt on one connector, you go and you plug it into something else, you've transferred that dirt. So you really need to be inspecting. The rule is you inspect it, clean it, and then inspect it again. So if you inspect it and it's perfectly clean, you don't need to clean it. Just go ahead and connect. And you should inspect both connection points before you mate them. So if you're plugging into a panel to test it, you need to be looking at the connector in the panel, not just the connector that's on your test reference cord. You need to be inspecting everything before they are mated to each other. Don't assume that everything is clean, even if you've just installed it. It's always good to check. Just a fingerprint can make a huge difference. If you get your finger on it, you can transfer a lot of oil onto that end face. And then spare reference cords. I think a lot of people don't even think about this. It's always a good idea to have a set of spare test reference cords for your fiber testers. What happens if you go to close up your fiber case? You've got a hard carry case for your fiber test equipment. You've got a connector that didn't quite go all the way into the case, and it's hanging out the side, and you close that case, and now you've damaged it. So any other number of things you can easily damage fiber reference cords. So it's good to have a spare set of reference cords with your kit as a backup. Some other keys to successful testing: correctly setting up the optical loss test system software. If you don't know how to do this, reach out to your manufacturer of your test equipment. At AEM, we offer free training, so we walk you through this. So when you get a piece of test equipment, we're going to take you through from A to Z and show you how to do these types of setups. If you're not sure, read the manual. It's always available. If you've gotten one of our testers, you're eligible for free training, and so on. So use your resources, whether you have our unit or not. Make sure you consult the manufacturer of your test equipment to make sure you're setting it up properly. Another thing that's often overlooked is a proper set reference. So there's a couple ways to do set reference that I'm going to talk about. The main two are 1 jumper and 2 jumper set reference. Back in the old days, we'd have if it's just a standalone light source and power meter, you'd put a cord on each, you'd couple them together, and you'd reference them. And then you'd uncouple them and you'd take them to opposite ends of the fiber and run your test. Now that's a 2 jumper set reference because you got 1 jumper on the light source, 1 on the power meter, and they're coupled together. Single jumper would be 1 cord from that light source to that power meter, and you set the reference. Then you disconnect at the power meter, and this is important. You don't disconnect at the light source after you've done a set reference, because your set reference will be blown if you do that. You have to disconnect where it's connected to the power meter port or the receive port. You disconnect, and then you add another reference cord to that power meter, and then take those to opposite ends of the link and make the measurement. And I know some people out there are thinking, oh, wait a minute, we've added another reference cable. We're going to induce loss. We're introducing loss into this that we wouldn't normally have. The reality is that 2-meter reference cord doesn't have much loss at all. The connector that's plugged into the power meter port is a free space measurement. It's not a connector to connector mating, so you're not going to see that. What you're going to see is the loss where you mate 2 connectors. So we want to measure that where we mate 2 connectors. That's why a single jumper reference method is preferred, and then adding that second reference cord. And part of your normal practices should be that you test that to make sure that reference cord doesn't have high loss. And you can save that in your test results as well as part of your job record. But once you've done that, you go ahead and connect it opposite ends of the cable and run your test. If you've referenced with a 2 jumper method, now again, when we're using a dual-ended tester, we've got 2 cords on each unit when we're doing this. Only 1 cord on each unit for the set reference, and then we add another cord to each unit. So now we've got 2 cords. But if we did a set reference like that, while it's acceptable under the standards, you could potentially mask the loss for that mated pair. So when you take that power meter to the other end and you plug it in, you can hide some loss potentially. So the single jumper is actually much more accurate, though both are acceptable, and you may use either one, whichever is more comfortable for you, whichever one you're more familiar with. It's perfectly acceptable. But what we do, and most manufacturers do, recommend that you use the single jumper method. Some other keys to successful testing. I've mentioned cleaning before, and this is number 1 on the list. Inspect, clean, inspect. Make sure the technicians are trained on how to use it. Again, I talked about training. Use the correct high-quality test reference cords, which are in good condition. So correct reference cord is key. I've had people actually try to run a test, and it turned out they were using a single mode reference cable with a multi-mode, or a multi-mode reference cable with a single mode test. It can happen. So make sure you've got the correct cords. Again, after setting your reference, you want to measure your test reference cords, and you can save that as part of your project. That's good practice. For multi-mode, ensure that you're setting up for an encircled flux compliant test. I'm not going to deep dive on EF here. If you're really interested in that, we have a webinar we did a while back on our Bright Talk channel on encircled flux compliance. You're welcome to go check that out. But essentially, you want to make sure you're EF compliant. So either your light source needs to be EF compliant at the transmit port, which for AEM's Test Pro and Network Service Assistant, We are, which means you can use our standard test reference cords. You don't have to have a special cord that's expensive and has a mode conditioner. But if your tester is not EF compliant at the transmit port, it's probably going to come with a special mode conditioning reference cord. So make sure that you use that on the transmit port on each side. Remember, we're doing a dual-ended test. You've got a transmit port or a light source on each end. So you need to have one of those on each end. The thing about those, if you break them, they're pretty expensive compared to a normal test reference cord. So treat them very carefully, guard them with your life. The other one that you see here, this little orange spool here, if you will, is a mandrel. And you'll need to do a mandrel wrap if you don't have either an EF compliant transmit port or a reference cable that does mode conditioning. So keep that in mind. Will it work for my application? So this is just, a quick rundown of, most testers will actually show you based on the way you set the test up, what speed you can run over this. So you'll know that as well. Some common causes of failure. I mentioned cleaning, test reference cord mismatch, incorrect test setup, failure to perform the set reference properly. We've talked about all these already. Then it comes to a problem with a cable or connector may be part of the issue. And if you can't figure it out, get an OTDR and hook that up. Test documentation is important, so make sure you've got capability to do test reports for your customers. We'll skip over the summary. I think we've covered all this, and we want to get into the live demo. But just so you know, the features that we talked about, the fiber testing is available in a loopback test in the Network Service Assistant, and in the Test Pro, it's available in a dual-ended, bidirectional, dual-ended, single-directional, and a loopback if you need to do that. Some of the other things that you can do, again, the integrated VFL, DC voltage and loop resistance on the Test Pro that I'm going to show you right now. And then with the Test Pro or the NSA, again, it's a loop back and you can measure voltage, but no DC resistance with that. So with that, I'm going to just drop this off. So now you should be able to see, I've got a Test Pro here. I've got it hooked up to my, my VNC. So you can see the screen here on the left of the display here. And what I've got set up here, I've already done a set reference. I've already connected to my fiber. Everything's been cleaned and examined. So one of the things I've got here, we've got a piece of hybrid powered fiber. So I've got my 2 strands of fiber here, and I've got a red and a black electrical conductor here. So what I'm going to do, coming out of the top of my Test Pro here, is a jumper that plugs right into it. And I'm going to connect it to this fiber. And we're just going to go red to red and black to black. And on the other end of this, I've got my Test Pro remote unit, and it is hooked up. And I'm just going to unplug from my receive port here just to show you when we connect, we actually get a live wire map. Just like with copper, we get a live wire map. So I see I've got connectivity on my fiber. I see that I'm already measuring resistance. I see I've got resistance on my copper pair here. So all of that's available there. Some of the other things that are in here, you've got in the expert tools, you've got your fiber inspection. So we can inspect the connector end faces with the fiber scope. We've got the VFL built in. So if I click on the VFL and I turn that on, I've got a 2.5 millimeter universal port here. So that's the standard size of an SC or an ST connector. And it gives you that VFL capability. So that's all built in. Standalone light source and power meter mode will let you measure it'll let you measure the absolute power or relative power you can set it for. You can also measure voltage if there's voltage present. And then the DC set reference is used when I first set up to set the reference for the electrical measurement. Your set reference button in here is where you go to choose 1 jumper, 2 jumper, or 3 jumper set reference. And we've already done a single jumper set reference. And for project setup that we talked about a little while ago, we can go in and we can set our fiber. We can set it for loopback, dual-ended, single direction. You can use generic fiber. There's a fiber library in here with a lot of manufacturers' model numbers in there, so you can choose that. You can choose your test limit and enter connectors, whatever you need to do. So we're going to go back and we're going to go ahead and we're just going to run a quick auto test. And you can see we're running a dual-ended single direction. We're running a reference grade. And we'll get not just our fiber test that was successful, we also see the resistance. This is part of the test record. So this is going to show up on our test reports now. Remember, we talked about that documentation. So not only will you have the loss of the fiber on the documentation, but you are also going to have the resistance, that DC resistance for that copper pair. We see we've measured the length of this cable at 19 meters. We've got our delay here. We see our margin at 1310 and 1550. If we go to our loss tab here, this is where we can see that loss by strand. If this had been a bidirectional test, it would have given us 2 more lines of data here. This was a single direction, dual-ended, but single direction. And this is at 1310, and then we can see the same information for 1550. We can see our limit, our margin, what our actual loss was. And then the really cool thing is this network limits. We talked about, will it work for my application? So one of the things that you want to look at, and this is calculated based on what type of fiber you chose. Did you select OM2, OM3, OM4, OS1, whatever the fiber was that you selected, and the length of the fiber, which was measured when we did the test, and the loss that we measured over that fiber. So all that information, you've got the loss, you've got the delay, you've got the length and the type of fiber, and it takes that information and it compares it against the known standards that are out there and what is required to be able to run certain distances for these speeds. So this tells us that based on all of those test parameters, we can run gigabit long wave here. We can run 100 gig base ER4, LR4, 10 gig. So we've got 100 gig here. So all these, and we even go to some fiber channel and FDDI, some old stuff here, going old school on everybody, the ATM. So you can see all the different things that you can run over this. This information also translate over to those test reports that we mentioned. So once you save this, which I'm going to do right now, I'm just going to save my test, and I'm going to do a save as because I have a short cable library here. So I'm just going to tell it it's an A5, and I'm going to save that. And once that test is uploaded to our PC or upload, to the Test Data Pro application on the PC, or you've uploaded it to the cloud, you can view those PDFs or send the PDFs to a customer. You'll have this information in addition to the loss of the fiber, how it was tested, what the reference power was, when the set reference was done, all these things, as well as at the bottom of that test report, you're going to see this information right here that shows up for your network compatibility. So you'll know based on that test, on the test report, what you can run over that fiber. So I'm going to go ahead and switch back over to my camera now, Jacqueline. And we'll see, did we have any questions that came up? Do we have an MPO connector test solution? Currently, we do not have an MPO connector test solution. What you would need to do is create what we used to call in the telco twisted pair days, an octopus cable, essentially, where you'd have your MPO and then have a breakout with the multiple connectors, and you would be testing 2 strands at a time. So currently there is no MPO test solution with Test Pro. We do have a product that is called Wide Optics. It's designed more for the carriers, the deployment for looking at multi-mode MPO, but it's not an optical loss test. It actually is a test where we actually run 25 gigabits per channel over that to test that in full duplex mode. So it's a little different, not really a field tester. It's a pretty large piece of equipment. But for field testing, we do not have an MPO solution at this time. And any other questions, Jacqueline? I don't see any here. If we don't have any other questions, just to let everybody know, in 2 weeks, Lisa Schwartz will be hosting, and she's going to have a special guest with her. Dan Critch from Cable and Connections is going to be joining Lisa in 2 weeks. I will actually be out of the office, going to take a week off and try and relax. So Lisa will be hosting when we return in 2 weeks. So thanks everybody for joining us. Really appreciate your time and look forward to seeing you on the next episode.